Okay, so this is on page 20 in your packet with parts 3 and 4 of chapter 15. So here we go. All right, so this first one, here's your tree diagram. And then the problem asked, what's the probability that you would go to Whataburger if it is known, given that you are a senior? Okay, so with that being done, then you put all of the senior down on the bottom, and that's what I have highlighted here. Those are the two ways in which you could be a senior. And then the part that is on top is Whataburger and senior. That's 53%. Okay, but let's talk about this check for independence and giving statistical evidence, okay? Because you cannot just go, yeah, they're independent because the fact that you are a senior makes it more likely to be going to Whataburger, and not show the math or the formula involved. You have to show the math or the formula. So you need two things. You need a conditional probability and you need the marginal probability. Conditional would be like a given that. Okay, so conditional would be a given that. So I chose this given that statement, and you could choose any of them. You could choose probability of not going to Whataburger given that you're not a senior. Probability that you're a senior given that you didn't go to Whataburger. Whatever. Any conditional statement. And then I chose this one because that was the one that was in part A. That way I didn't have to redo the math. Okay? So I did that one. And then you go to the marginal would be this first one overall. So whatever this first one is, that's what you do overall. So go to Whataburger overall was 36%. Okay, and then the part from part A was 53%. So here's how your statement goes, because I've had questions on how do you know which words to say in your statement. And here's how you know. You start in the back of the conditional. You say this. The fact that you are, whatever this is back here. So the fact that you are a senior, and then you see what it does to the probability of you going to Whataburger. And I go from here to see what effect happened. So the fact that you're a senior made the probability of going to Whataburger increase from 36% to 53%. Okay, so that's how you would say that. All right, this next one had three pieces here. Dating somebody not from AHS, dating somebody from AHS, and not dating. And then it asked, given that you date someone not from AHS, it's a probability you're a male. That came out to 52%. Now, so when I checked for independence, what do you need? Two things. What's one of them? You need a conditional statement, and then you need the marginal that corresponds to it. So I used the conditional I had previously done, and it's 0.52, and then overall male is 0.52. Now, so according to that, it appears as though dating somebody not from HS and being a male, those two things are independent. Okay, because they were the same probability. The fact that you date somebody not from AHS didn't change the probability of you being a male. But here's the thing. Do you know that if I was to make a statement about overall gender and overall preference at AHS, I would actually have to check every single one of them. I would have to check all 6 things, okay, and see that they are all the same. Okay, somebody had done that in my other class and found that one of the other ones showed a different number. And so the whole entire gender and preference were not independent. But anyway, yes, question. I got that the bottom number is 0.2. Yeah, this bottom sum is 0.2 because I did 0.52 times 0.2 plus 0.48 times 0.2, and that's 0.2. So check there, see what happened. Okay, all right, moving on. Here is the relationship between high temperature and flu. So the probability that you have high temperature, or the probability that you have the flu, given that you had high temperature, was 80.15%. Okay, so see how you did there. Now, let me ask you guys something. Let's just take this one step further like it did on the front. How would you check for independence here? Give me a conditional probability here. One of them. What is it? Which one you want to do? Oh, you want to put high temp here? Okay, I could. I could say, what's the probability of having a high temp given that you have no flu? Okay, I could do that. And then if I did that, what would be the marginal that I would check? The overall high temp. Okay, now I'm going to tell you these numbers here would be very difficult to check. Okay, why don't we use the conditional that we had already done? Let's do that one. Okay, since we already had done, but you could do that. It would just be a little bit more work. So let's do the one we had already done. Flu, given that you have a high temp, because I know that that's basically 80% chance. And then what would the overall marginal be? The marginal be I check. Okay, if this is the conditional I'm checking, what's the marginal I check to go along with that? Good. Flu overall. It's whatever this first one is. And I can see that that flu overall is 35%. So, how would I start my statement? It would say, the fact that you have what? High temp is doing what? Increasing the probability of you having flu. Okay, and the last one. Probability that you earn over $100,000, or I'm sorry, the probability that you're a Republican given that you earn over $100,000 is 73.8. Okay, let's do the test for independence one more time. Pick a conditional. Let's pick the one that we just did. Republican, given that you make more than 100,000, is about 74%. What marginal would go with that? Republican overall. And Republican overall is 15%. So, my statement begins. The fact that you, what? Nope, the fact that you make over 100K, that's the given part. Does what? Increases the likelihood of you being Republican from 15% to 74%. Okay. All right. Now check the warm-up. Here we go. I sent you a text yesterday that had a hint about number one. The hint said, they tell you that this entire circular region totals up to 60%. But, hold on. They said 39% are dogs and 34% are cats, and that totals 73%. How can that be? Good, because when they added 39% plus 34%, they double counted this 13% in the middle and got 73 instead of 60. All right, so that tells you what the overlap is. So A is 40%, B is 13%, C is 33%, but I want to have you be mindful of if you made a mistake here. If you put 0.34 over 39 for this problem here, that is not correct because you put all of the cats over all of the dogs. You do not put all of the cats over all of the dogs. You have to put the intersection cat and dog. This has to be 13 on top, not 34. Okay? Then here's what your tree diagram looked like. Out of all of the defective, which is those yellow branches there, what's the probability of getting that blue section? And that's 34.78%. 34.8%, somewhere along those lines, about 35%. Okay, yes, question. Yes, this is number 2. How did I get the answer? Okay, so I put all of the defective ones. It said, what's the probability of it being from company B given that it is defective? So I put all the defective ways on the bottom. Oh, you know what? Be careful and make sure that for this 0.5%, you made that decimal 0.005, by the way. So on the bottom was the A defective, which was 0.10 times 0.04. The B defective, which was 0.2 times 0.02. And the C defective, which was 0.7 times 0.005. That's the bottom. Then the top is the B section of that. Okay? All right, here's the back. What you want to be mindful of is the denominators. A says, what's the probability that a randomly selected student? So that denominator is all the students, 331. B, what's the probability that a randomly selected student? So again, that denominator is 331. C, same thing. What's the probability that a randomly selected student, same denominator of 331, this time it says is 2 things, the intersection of female and eating breakfast. So female and breakfast is the intersection 125. Okay? Now, I don't like that D and E's wording were actually pretty simple and straightforward because they both said straight out, given that the student ate breakfast, or given that the student is female. I think that that's, fundamental that you know that, but I want to say to you a couple other ways that the statement might be read and that it might hide from you that it's a given that statement. Okay? So I'll do that in just a second. But D put all the breakfast eaters on the bottom, so that was 191 on the bottom. And C put all the females on the bottom, so that was 199. So, if I said this, what's the probability a female ate breakfast? This is also a given that statement. If I say, what's the probability that a female ate breakfast? This is a given that. What am I given that on this? No, I'm given that it's a female. What's the probability that a female ate breakfast? Okay, so be mindful that it may not straight up say given that or if it is known that. Okay, all right, yes, question? Oh, okay. All right. And finally, the last one is about a check for independence. So what 2 things do I need for an independence? First thing I'm going to get is a what? A conditional. First thing, do a conditional. I went ahead and did the conditional. Given that it's female, what's the probability you ate breakfast? You could have done something else. In fact, on my answer key for these quizzes, I have 3 whole pages attached to the quiz that has all the possible things you could have done for this type problem so that I could check whatever you did. Okay? All right, and then you do the marginal that goes with it. In this case, how would I write my answer? The fact that you are female does what? Increases the probability that you have what? Eaten breakfast, okay? The fact that you are female increased the probability that you ate breakfast from 58% to 63%. Okay? All right, any other questions? Yes.
So is I don't know, the probability that your female who ate breakfast is being compared to the overall eating breakfast?
Yes, the conditional female eating breakfast is compared to the overall marginal eating breakfast. Yes. You do not compare it to the males eating breakfast. You compare it to the overall marginal. Yes, next question.
The marginal, I have the probability of eating breakfast, and then
Okay.
given that you're female, and so when I did the description, I said not independent because the fact that you're female does not change the probability of eating breakfast.
I think it does.
So it does. So if
Yeah, so your math might not be right.
so if the yes I got 57.7%, and the yes the female is 65.5, so I just say that it increases the percentage.
Yes, from 58 to 65 or whatever.